Hello. Welcome to my YouTube channel. This is Bogar Henry presenting to you my project, artificial intelligence project called the hate speech detection. Yeah. So the context today I'm going to talk about problem description, dataset description, factors influencing the usage of the dataset, then Bayesian theorem, naive Bayes, then Bayes networks, comparison between Bayesian theorem and naive Bayes, and then comparison between naive and Bayesian networks in the reference. Okay, so hate speech on social media in broad, this is a real life problem I want to solve using artificial intelligence. So hate speech refers to the offensive discourse targeting a group or an individual based on inherent features, that is religion, race, or gender, and this threatens social peace. Can be conveyed in any form of expression, including images, cartoons, names, objects, gestures, and symbols, and can be disseminated offline or online. Hate speech is discriminatory, that is biased, bigoted, and intolerant. Or in other words, I can say it's pejorative. Okay. And then understanding and monitoring hate speech across diverse online communities and platforms is the key to shaping new responses. So I have decided to use a data set, an open data set called the Dynamically Generated Hate Speech Dataset, and it's first of its kind synthetic training dataset for online hate classification. It's created from scratch with trained annotators over multiple rounds of data collection. It's provided in two tables. The first table is a dataset of entries with entry ID, label type, annotator ID, round state split, round model predictions, and whether the model was fooled. The second table is the targets of the hate in a white format. Why did I use this dataset? Well, with this dataset, you can define the guidelines for generating valid examples of hate speech that improves the effectiveness of the model. Whereas it has more challenging examples that enables us to train better models. It controls around 40,000 entries, of which 54% are labeled as hate speech and is of help when solving the hate speech problem. So I'm going to talk about Bayesian theorem. Bayesian theorem is a method to determine conditional probabilities, that is, the probability of one event occurring given that another event has already occurred. Because of a conditional probability includes additional conditions, in other words, more data, it can contribute to more accurate results. So the methodology is, okay, I was giving just an illustration where Bayes' theorem was illustrated. Okay. So I'm going to also talk about naive Bayes. Naive Bayes algorithm is a supervised learning algorithm which is based on Bayes' theorem and used for solving classification problems. It's mainly used in text classification that includes a high-dimensional training dataset. Naive Bayes classifier is one of the simple and most effective classification algorithms, which helps in building the first machine learning models that can make quick predictions. It's also probabilistic classifier, which means it predicts on the basis of the probability of an object. Sample play examples of naive Bayes algorithms are spam filtration, sentimental analysis, and classifying articles. Okay, we'll talk about the cons and pros of the theorem. The pros: it's easy and fast to predict class of test data set. It also performs well in multi-class prediction. When assumption of independence holds, a naive Bayes classifier performs better to compare to other models like logistic regression, and you need less training data. The cons, there is assumption of independent predictors. In real life, it's almost impossible that we get a set of predictors which are completely independent. So we also have what's called Bayesian networks. These are widely used class of probabilistic graphical models. They consist of two parts, a structure and parameters. The structure is directly a cyclic graph that expresses conditional independencies and dependencies among random variables associated with nodes. The parameters consist of conditional probability distributions associated with each node. So this network is a compact, flexible, interpretable representation of a joint probability distribution. It's also useful in knowledge discovery as directed acyclic graphs allow representing causal relations between variables. So this network is learned from data. So I had some illustration, and maybe you can look through it. So I got some differences between Bayesian theorem and naive theorem. No, a naive Bayes. Naive Bayes assumes conditional independence, while Bayesian theorem does not. Bayesian theorem states the relationship between joint distributions and conditional distribution, while the naive Bayes is just a simplification of Bayesian theorem. So I also got one difference between naive Bayes and non-Bayesian network. Naive Bayes assumes conditional independence, whereas more general Bayesian network will allow the user to specify the attributes, which attributes are in fact conditionally independent. So these are some of the references I used.